500 lives shared by every player in our survival series. Each death chips away until we reach the finale, and at the end we lose access to survival and become spectators. I'm going to walk you through every command used to build this data pack in vanilla Minecraft, break down the file structure you need to know, and at the end we'll rewrite the project using Beet to supercharge the pack development process. If you already know a bit about data packs, skip to the timestamp on screen to dive into Beet. So what is a data pack, and what are mcfunction files? Data packs are Minecraft's built-in method of letting you modify the game without actually programming a mod or writing your own code. We can use these to define our own advancements, dimensions, structures, among other things. The focus of today's video is the functions feature of data packs. Let's go over the file structure. To create a data pack, we can start by simply creating a new folder with a good name. I'm the admin of Jumbled SMP, so I'll just use Jumbled for now. Inside of this, we'll create a new text file and rename it to pack.mcmeta. I'm going to use an online tool to generate the contents of this file for the version of Minecraft I'm using, and I'll have this linked in the description. That's a bare bones data pack. Let's make sure this loads in game. For now, we'll load our instance of Minecraft and create a new world. We see a button for data packs, which we can click, and then click Open Pack Folder to open a file browser window where we can copy and paste the root folder of our data pack or the contents of it in a zip file. We press Done, and I'll do Creative, Peaceful, Super Flat for now. Now that we're in game, we can also check that our data pack is loaded with the datapack list command. We see File Jumbled enabled for this world save. You can also add data packs by finding the folder on your computer for the save and adding them to the data packs folder shown on screen. Back in our root folder that we pasted, we'll create a new folder called Data. Inside of that, two folders, Minecraft and Jumbled. We'll come back to the Minecraft folder, but for now let's get into Jumbled and create a new folder called Functions. If you're writing a data pack for 1.21 or higher, you'll name this function without the S instead. Inside of that folder, we can finally start writing mcfunctions. Let's create a new text file, rename it to on_tick.mcfunction or a similar fitting name, and add a simple say hello world. A function or mcfunction file is a list of Minecraft commands that are executed in the order they're written from top to bottom. And note that we don't need to have the / at the beginning because Minecraft expects the contents of these files to be Minecraft commands, or commented out unused lines beginning with a $. In game, we can use the reload command, which occurs nearly instantly for us because there's not much going on, followed by the function command, and we see that Minecraft offers to autocomplete our function, the only one defined, onTick. And if we run this full command, we see hello world printed to the console. Let's go back to onTick, add a couple more say commands, reload, and run our function again. We see the expected messages in chat in the order that they're written. Say isn't very powerful, but remember that we have access to every command that exists in Minecraft. This includes give, game mode, game rule, etc. So we could write a function that sets us into creative mode, gives us a netherite axe, and enables the immediate respawn game rule, all executed by running this one mcfunction file. You're probably already thinking of everything that's possible, but let me show you two tags that we can add mcfunction files to. One that makes our functions run when the world is loaded and after reload commands, and another that runs our mcfunctions every game tick, or 20 times per second. Tick and load.json in Minecraft's namespace under tags functions. We'll go back to the Minecraft directory we created earlier under data, create a folder inside named tags, and inside that a folder named functions. Let's create a new text file, rename it to tick.json, and we'll add the following contents between some curly braces. The key replace with a value of false so we don't override previously tagged mcfunction files, and the key values set to a list of values, one of which is the full resource location of our function, jumbled for the namespace, and the name of our file, on_tick. Back in our onTick function, I'll replace everything with say commands, and we'll reload the game. Instantly we get spammed with all of these messages because that code is now running every single game tick. Let's undo that and clear onTick for now. We'll come back to it shortly. As a quick side note, we're going to be using Visual Studio Code for the rest of this video. The reason being there are tons of extensions that can enable you to write data packs a lot faster. Some of them, like Datapack Helper Plus, won't be useful for us later when we're using Beet, as it doesn't have support, but I found this one, syntax mcfunction, and this one does specifically mention Bolt and JMC, and of course later on make sure you have the Beet extension as well. Let's do the same thing for load. Create a new text file in that same tags functions folder, rename it to load.json, and give it the same contents, replace false, and values pointing to a new function we'll call jumbled on load. Then back in our jumbled functions folder, create on_load.mcfunction. Anything we put here runs once when the world is loaded, and again whenever we use the reload command. This is where we put setup logic for things that need to exist before anything else runs. Now we can actually build the system. The core mechanic here is a shared pool of 500 lives that every player draws from when they die. To track numbers like this in a data pack, we use the scoreboard command. The scoreboard command has an argument for criteria. Minecraft provides some of these default values for us, which changes how the objectives we create actually operate. So the main two that we're going to be using are dummy and death count. So dummy can only be changed by commands, whereas death count is automatically incremented when a player dies and can be changed by commands. So this one will automatically update and then we can reset it. After we give this as an objective to players, score updates when they die and we can detect a death via that. So in the abstract, this is what we need to do. When the game loads, we set up our scoreboard objectives and give them default values if needed. And then every tick, we're going to check if someone died, remove a life from the server total, or trigger the game over sequence and put everyone in spectator. Let's play around with the scoreboard command and see what we can do with it and see how we're actually going to build out this system. So we type out /scoreboard, we do objectives, we can use add, list, modify, remove, set display. So if we do list, there's nothing there. There are no objectives because we haven't defined any, and there are none loaded by Minecraft Minecraft itself. I showed you criteria earlier, and so if we try to add an objective, we need to give it a name, and we can give it the criteria here. And like I said, we're going to be using dummy and death count mainly. So if I start with dummy, this can only be modified by commands, but even if I do that, and I do scoreboard players get lives, even if I try to get that, there's no value set yet. You actually need to give that value for each individual player. And you can do this with like entity selectors. You could do like an @A to select all entities or all players or whatever. But what we want to do is actually have the total lives tracked by a fake player, not on a specific player that's playing in our world. So we can use a specific notation to like make it more obvious. But what we're going to do is scoreboard players add, instead of targeting a specific entity or targeting a specific player, we're going to do a $sign and do total. So the $sign is not really a valid character when you're creating a Minecraft account, but we're allowed to type it here to use it as like a placeholder so that we know this isn't a real player name. Now we do the objective that we created, lives. We need to end off with the actual score value. So I'll do 500 because that's what we would be starting with. So we get added 500 to the lives objective for the fake player total. So the value is now 500. So now if I do scoreboard players get, instead of IamJason13, we'll use the fake player name total, and now we get total has 500 lives. So how would we display this? We can do scoreboard objectives set display, and I'll do sidebar for now, lives. And now we get the fake player with the 500 lives total displayed under the name lives. Now you can also modify scoreboard objectives. So we'll do the modify subcommand, lives, and we can actually update the display name. So you can't just type out text like this. You could just do it in quotes. So this is possible. So now we see it's test over there on the right. Now something you can also do is create a JSON object basically with the text keyed to some text. And I believe you can do color as well. So we'll do that, and now we see it's changed to server lives over there. Now, typically, I'm not going to have this displayed. I also want to show you that we can copy and paste some Unicode characters. So instead of having server lives right here, we could do that Unicode character, and we can also use it as a target as a fake player name. So we could have a heart displayed over there on the right as well. And alternatively, you see this 2764 I have. I'm copying this here. So we're doing a /U2764. Then I'll add some text after so you see it updated. So you could do that / if you want to type out the actual number of it and not worry about having that Unicode character. So I'm going to remove lives here, and now we see everything is removed. So if I try to get that score, it doesn't exist anymore. So back in our onload function, we're going to start when the game is loaded or after the reload command, ensure that this lives objective exists. Even if it already exists, as long as we're not changing the criteria or trying to modify it some way during the add, this causes no issues. So what we were doing is scoreboard player set fake name lives to 500. Now the issue with this is that this code will run every time we do reload. So even if we were mid-session and there were some bugs or something and we tried to reload to reset something, it would set us all the way back to 500, and that wouldn't be very good. So we only want to execute this specific line of code if there is no value in place for it yet. So here's the scenario. So as an example, say we were down to 250 lives and then we go to reload after changing something else in the mod pack, and then now our lives are set back to 500, and that's not what we want. I'll do execute unless score total lives is equal to total lives. And we'll do run scoreboard players set total lives 500. So what we're doing here, we are executing unless the score of our fake player lives is equal to the score of our fake player lives. So if that objective doesn't exist, then this would fail, so we would run because we're using unless. So it negates this. And then we're running scoreboard players set fake player total lives to 500. So if that objective doesn't exist, then we set it for the fake player to 500. We try to run this now and nothing happens because the fake player already exists with that scoreboard objective, so that does not run. So we could just copy this real quick and go to our onload and paste that in there. Now we do reload and nothing happened because we have that unless in there, and the scoreboard objective already existed, so we couldn't update it. So we have our abstract player total with 500 lives. Now we actually need to detect the death and do an onDeath function to update that score when a player dies. Let's go back in game. We'll do scoreboard objectives add. We'll give it a name deaths and then give it the criteria death count, so it automatically updates when an entity with this objective dies. So let me do scoreboard players add myself deaths. We'll start at 0. So we do scoreboard players add myself deaths 0. Now if I do scoreboard players get then myself deaths, I have 0 deaths. So I do /kill then run the get command again, and I have one death. I'm gonna go back and copy this for adding the new scoreboard objective, and then on load, we'll do that after creating lives. I wanna go over these commands real quick. So scoreboard objectives add deaths, death count. I immediately did /kill after, and then scoreboard players get @s deaths. So what we're seeing here, the objective was created, I died, and because I died, that scoreboard objective was automatically updated. So I didn't have to actually set it to 0 for it to actually begin updating or anything. It was already being tracked and updated as long as it exists in general. That's different from our fake player lives because that is only updated by commands. So when the game loads, we make sure our objectives are created. If the lives objective for our fake player does not exist, then we create that and set it to a default value of 500. And then I added an extra line just to set the display for the lives, just for testing. So now that the deaths objective is created, that gets updated automatically when a player dies. We could do execute as any entity that has scores of death equal to a certain range. So we want to target if it's greater than 1. So there's this notation where we're basically seeing this is starting at 1 and going up to any value. Or you could do 1 going up to 10 maybe. Or you could start from 0 going up to infinity, or a negative value going up to 0. So this double dot notation for Minecraft like ranges, pretty interesting. You should learn about it. We're gonna check if it's greater than 1, and then we'll reset it afterwards in a different function. But for now, we're just gonna do run say I died. So I'm gonna do reload. Now if I do /kill, well, we see this get spammed because it's constantly firing every single tick, and so we should probably reset the value. So we're going to add a new function. I'm going to call this on_death.mcfunction. So inside of this, we're going to keep using the scoreboard command. We're going to do scoreboard players reset. We're going to reset the deaths for self. So instead of say, we're going to do run function on death. The game loads, we create a deaths death count objective. Then every single tick, if that value of deaths for any player is 1 or greater, then we run the function on death, and on death is just resetting that value. So let's do reload, and we're not being spammed anymore. That's good. So we'll do scoreboard players get myself deaths, and we see it says no value is set, and that's because we reset the value. So let me go back here. We'll do say I died right before we reset that amount. So let me do /reload /kill, and now we still get the I died message. But if we go back, that value says none is set because we did a reset on it. We could set it back to 0, but a reset is perfectly fine for detecting a death. So what we want to do next is use the remove sub command for scoreboard players. Now remove, it doesn't remove the objective entirely, like it doesn't take it away from the player. It'll still be tracked. We're literally just decrementing it by a value. So we're going to remove 1 from that objective for that specific player. So instead of 250, we should go down to 249. And this is what we want to do every time a player dies. So we're going to go back, copy this, and I'm going to replace the say I died here. So now we can do /reload, and then if I do /kill, I have immediate respawn on. So it just happens pretty fast, but you see the life is going down. So we can detect the score for a player, and that counts for fake players as well. We're going to execute if the score of our fake player total lives matches this range of less than or equal to 0, then run the game mode spectator for all players. So that works as expected. So we're gonna paste this in here. Let me go back to creative, set fake player lives 1. So we're back to 1 single life left, then I /kill, and it puts us into spectator mode. Now that is the very bare bones of it, but we're missing a boss bar. We don't have a nice display on it. There's no visuals, you know, it's just something that happens in the background. We have 8 commands. We have 3 that run when the game loads or after a reload command, and then we have some logic that happens every single tick. If some stuff is true, then we execute on death, or if some other stuff is true, then we execute game over. So this is the entire background of it, and I took out the set display list. Pure 8 commands. We create 2 new scoreboard objectives with different criteria. One is dummy, that only gets updated by commands for the fake player lives. One that gets updated automatically when an entity dies. So we have lives and deaths. So we reuse this in a couple spots. The fake player name, $total. Here we're checking with unless, so if the score is not equal to the score, then we're going to set the score to 500 for the fake player. Then every single tick, if something has updated the death count, then we'll run our on death logic, which removes 1 life from the total player, and then resets the entity that died's deaths. After we check for deaths, then we see if our total fake player lives matches a range of less than or equal to 0. Then we run game mode spectator at A. Well, this should actually be our function jumbled game over. So this runs that game over logic, game mode spectator for everyone. So it's pretty straightforward, but now we want to make it a little bit more visual. We're going to do a boss bar setup, and we'll even do the life counter that I showed you before in the intro. It only gets more complex from here. After we add the boss bar and life counter display, we're going to add Beet to our project to give us some advanced Python-like scripting abilities. As such, knowing Python can play a huge role in how well you adapt to some of these new language features. When I first tried using Beet, I had some issues with the Python syntax. I'm used to Java programming for when I make mods, so switching languages just for this felt a bit odd. So I took some time time to learn about Python through an online course offered by the sponsor of today's video, Brilliant. Usually when I'm learning a programming language, I tend to reference random examples of possibly good or bad code from across the internet to get a feel for how things are done. Instead of that guesswork, I wanted to find a resource that I can trust. Brilliant specifically offers a Thinking in Python course, which I just completed recently to get a leg up for this project. Learning isn't passive either. You're actively solving problems in their interactive lessons, walking yourself through the logic, and building intuition from the ground up. Their courses are crafted by world-class teachers from MIT, Harvard, and Stanford to teach you in a way that solidifies the concepts you want to learn. And beyond Python, they offer courses on math, algorithmic thinking, data, circuits, and even how AI works under the hood. To learn for free on Brilliant for a full 30 days, go to brilliant.org/Jason13, scan the QR code on screen, or click the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thank you again to Brilliant for sponsoring this video. Let's go over the commands we need to create our Bossbar, display it to players, stylize it, and update its value. So Minecraft has this concept of namespaces, right? So there's this colon in between this. Iron Sword under Minecraft is under the Minecraft namespace. An item or resource location under our namespace has our namespace before it. So you see this kind of separation between the namespace of whether it belongs to the game or a data pack, and then the actual location of what that thing is. So when we're creating a new Bossbar, we need to align with this and give it a resource location. Otherwise, if I try to do bossbar add test and give it some random name, well, it creates the custom bossbar name. If I do bossbar list, we see bossbar active name. But if we try to do bossbar get, we see it has the Minecraft namespace because we didn't specify a namespace. So we can remove test and it assumes that we're using the Minecraft namespace. So we're going to do jumbled : lives to have it under the jumbled namespace, and we're giving it the location of lives. Then we give it a display name as well. Even though we give it a display name, it's not going to display automatically. We'll go over that in a moment. You can also do text components for the display name as well. So we've added that. We created a custom bossbar, but for players to see that, we need to actually set one of the attributes of the bossbar. So we're going to do bossbar set. We're going to do our bossbar. You probably see visible and you want to go straight to that. And if you do true, it doesn't do anything. It technically is visible, but no player selector is given for us to see it. So we actually want to do the players subcommand. You could just do yourself and you'll see it. Typically though, you just want to do @a so that all players can see the bossbar. Or you could do @a within a certain distance. And this actually uses that Minecraft range that we saw earlier. So we have a bossbar, players can see it. It has some custom text for the name, but it doesn't have an actual value yet. So you probably saw bossbar set jumbled lives, and then we have the value subcommand. And if we try to do this though, it does set the value to 500, but we also have this max, which currently is not set. So what if we have the max at 250? Then we try to get the value and it still has a value of 500. So we don't want to be setting this value manually. Obviously, we're going to do this with a function, but how are we going to get this value? How do we know to do 249 instead of 250 or however many lives that we have left? We can go back to the execute command, which has a store subcommand, and we have an option to store the result of a command. And specifically, we can store those values to a block or block entity, a bossbar, an actual entity. We can change a specific score if we want to, or storage, basically being raw global data. So we're doing bossbar, our bossbar, we're going to store the value. So when we're storing the result of a command, we need to actually give it a command to run that will give that value to our scoreboard lives value. What we're really trying to do is get the scoreboard value for our fake player, and we want to get the fake player lives and store that to our bossbar. So we have a couple parts to this here. We're storing the result of a command, and where are we going to store that to? We're going to store that to our bossbar, and we're going to store that to the value in our bossbar. And then what value are we going to store? We're going to store the result of a command that we run, and that command is getting the remaining lives of our fake player. And you saw me doing this earlier. So we can run that. Total has 500 lives, and what we're seeing is the output of the final run command. So I manually updated these values. Now the max is at 500. We set the value to 250. Now let's go over color and style. Color is pretty self-evident, but we have a pretty limited range to choose from. So we can do red. Now the bossbar is red. Style is pretty cool. By default, we're using progress, so you see it's just pretty standard bar. We do one of these notched ones. The number at the end is how many segments there are. So if I do 20, you see there's now 20 segments up there. Or we can do 6, and now there's 6 segments. So one thing to note is that if you update it, when it's updated, it won't match the notches. So you might want to stick to progress usually. It's just for visual style. We could set up the bossbar inside of our onload function, but I'm going to create a new function, which is just setup bossbar. So we did Bossbar add, and then make sure we give it a namespace. And then I'm going to do a simple name for now. We're going to make sure we set the max to 500. You might be tempted to throw in the players that this is visible to, but the onLoad function loads before any players are in the world or any players can be selected by entity selectors. So this is not really possible. You would do this later in the onTick function. We can also set up our styling here. We can make it red and set up the progress styling. So at the bottom of our onLoad function, we can do the function command and run our jumbled setup bossbar. Inside of onTick, we'll do our execute store results. Just going to copy this real quick. So we're storing our fake player lives to the bossbar, and we'll also make sure that all players can see the bossbar. So I set the sidebar so we can see the actual number here. Let me do /kill a few times. Okay, took about 10 deaths, but now we see a tiny notch has been taken out of our bossbar. So what I could do instead is do scoreboard set fake player lives to 1, and now we see that update dramatically. So we have us as the player, and we can detect when we die, and when we do die, updates a scoreboard objective for a fake player that we have, and in turn, our onTick function updates our bossbar to display the correct value between the max range. So it's a multi-part system here. We're detecting deaths, updating a fake player life, and updating a bossbar to match those fake lives. And then at the end, when this reaches 0, it affects the player, and they get put into spectator mode. So we have a bossbar, we have a fake player, and an objective for tracking the amount of lives that we have left on the server, which gets stored into our bossbar so that all players can see it at any given time. Now, like we just saw, it took about 10 kills to see about where we were, and once we get lower and lower, we might want a more fine-tuned, like actual number display, and that's what you saw at the intro, and that's what we're going to go over next. And after that, we're going to dive into Beet. This next part is pretty straightforward. It's mainly about text components. We have this title command, and I'm just going to do the @s selector for now. And we have title, action bar, subtitle, and a couple other subcommands. Mainly what I want to show you is action bar. So when we're building a text component, I showed you earlier that we could just write out a string with quotation marks around it, and this works fine, and this will fade out momentarily. I also showed you this, where we did color and text as key value pairs, so you can display some text and add a color to it. Now, something else you can do, if we add these square brackets around this still works just fine, but we can also add more. You could do a raw string here, so we see display text, test, or as we just saw, we can replace those. So we have text, display text, which should be red, comma, text, hi, which should be green. So we see display text, hi. So this is looking a bit different now, right? We have score, which itself is creating a JSON object with the key name of our fake player name and the objective of lives, which we created earlier. So if I try this, now we see display text 500. I'll link this website in the description. So I built out a text component that I liked. We run this, we see lives 500 over 500, and we would put this in onTick to run every single tick. So I'll copy that, and I have that at the end of my onTick function. So now I can just do reload. We'll see that there, do kill, and we can see it update every time. Hey there, if you skip to this point, what you're seeing now is the complete vanilla data pack. Let's talk about Beet, the self-described pack development kit for Minecraft. Quoting their rationale document, Beet is here to introduce a build step to rescue you from developing directly in your .minecraft folder, which I've been doing. So I'll create a new repository on GitHub for this demo. And we'll start with the very basics again, leveraging parts of Beet and its subpackages Bolt and Mecha along the way. There's also Lectern, which I'm extremely interested to look at towards the end. We've got an empty folder for our repository. Let's create a new file, beet.json, and add our datapack name and description to start. Now we want to add require with Bolt as a value in a list, which tells Beet that our project uses some of the features provided by the Bolt subpackage, specifically the Python scripting ability. We'll add a datapack key as an object with keys load and pack format. Load is indicating the folder that our code lives in, and pack format is specifically related to Minecraft Datapack versioning. I'm using Minecraft 1.16.5, so my pack format would be 6. Next, we add the key pipeline with the value of Mecha in the list. And note everywhere that we're using lists, you could require other projects, load multiple data packs, use multiple pipelines, etc. Now we'll add output, key to a value of build, to specify where our final generated data pack should be written to. And I'll end off with the version of Minecraft that I'm developing for, as the format and arguments of some commands have changed over time. In general, nothing changes right away. We can even import the vanilla data pack we just created, run the beet build command, and we'll see that the same commands are copied to the build directory. We added Bolt and Mecha. These Beet subpackages work in tandem to give us access to high-level Python abstractions for writing mcfunction files. Watch what happens when I define a basic array of strings in a single variable. We can use these in say commands and other places as variables now, and this is what the final file looks like. Pure commands without the additional syntax just draw execution of our abstract logic. So it gets more complex when you want to use one of these variables within a string, right? It seems like I have a lot going on, but it's all just say commands, okay? We define an array of strings, we say hi, we define a number, we say that number. For every string, in our string array, we say those strings, test1, 2. We say hello world. Now we have 4 fake names. We change the value of the number that we defined earlier, and then we change the index of our fake name to be our new number. And then we use that updated fake name in a say command, and we say 3. Then we do a say with the value of our number again, which is also 3. But then here we try say with a longer message. So when we try to do this, we see say X is my number, and the player would literally see X is my number in the chat. Now, what we're doing here is a formatted string. This is a feature of Python. This isn't something you could do with vanilla commands. But what this compiles down to, this F in front of this quotation mark says that we're going to use some special formatting inside of this, and these brackets around the X replace this value with the value of X. So now we properly see 3 is my number in the chat. Then we go back and iterate over every name. We say the name by itself, we say it in a longer string, and then we say it replacing that value in the string. And that's what you're seeing here for this final block. So we have this concept of variables that we can reuse in singular logic in the same file basically. But what if we have a list of constants that we want defined for our entire data pack that we want to reference from anywhere in the data pack? Bolt has this concept of modules. If we create a new modules folder under our jumbled namespace, we can put some new files in here, and these are going to be .bolt files. So I'm going to start with constants.bolt. In the vanilla data pack, we were using this shorthand of $total for our fake player name. In previous versions, I used a longer name of jumbled total instead. So we have a longer name that includes our namespace, or if you need to, like a shorthand of it, so that anybody else using scoreboard objectives can still use the shorthands, or so we don't accidentally mix up with other data packs if you are mixing data packs. So I'm going to set up some constants. We're going to have the fake player name, and I'm going to have the shorthand as fake, but in the compiled data pack, it'll come out to jumbled total. I'm also going to have constants for our deaths and lives. So we're going to use these shorthands as we write the data pack, but the final compiled data pack, after Beet compiles it and it's in the build directory, is going to have these longer names, so we can avoid conflicts with other data packs. We could also put some of our other constants here, like our starting lives. We can put the resource location for our Bossbar ID here as well. So now that we have these constants, how do we actually use these in our MC functions? At the very top of our file, before any of this gets processed by Bolt, we're going to do from our namespace jumbled, from the constants module that we just defined, we're going to import deaths, lives, and our fake player name. So that matches fake deaths lives here. We import fake deaths lives here. We need to replace these totals with our fake, so that it uses the fake player name. Let's run beet build. So we created a module named constants, and from our module named constants, we imported the fields deaths, lives, and fake. So these specific words will now be replaced as our file is processed. And you can see down here in the built file, it's now using jumbled lives, jumbled deaths, and jumbled total. So I don't really like the fake player name here. I might change this to jumbled fake, but now you're seeing a huge benefit of Bolt. I only have to change this in this one specific place. And now anywhere that's already using that fake variable, if I build this code, you see that gets updated instantly in all 3 of those spots, instead of me having to edit this file and edit each of these names at each location and make sure that I update every single instance of it. So we also have starting lives, so we can import that. And Bolt gives us a shorthand for unless here. Instead of having this longer line, I'm going to grab this part, unless the score of our fake player lives equals the score of our fake player lives. I'm going to paste that. This is pretty much an if check in raw Python code. So we described this earlier. We're seeing if our fake player already has the lives objective handed to them. And if they don't, then we want to set that. So we can copy this part and put this here. So we're taking out the execute and the run basically, and formatting it a little bit neater. And since we imported starting lives, we can replace this here. And then I'll comment out the original line and build this. So it built, and it doesn't seem like anything changed, right? Because it's the exact same logic, just written in a different fashion. That's a lot neater, a lot cleaner, and more extensible. So I've just imported all of our constants into our onTick function, and we're going to start going through and replacing all of the instances, such as like fake player lives and the objectives and stuff, and making sure that the compiled code comes out properly. So one thing I was worried about was this deaths here inside of the scores. We check this, and this comes out with jumbled deaths as expected. Let's replace every instance of our fake player name with the shorthand for our fake player name, and let's build that. So we see jumbled fake in 2 correct locations, but here we're seeing the shorthand fake where it shouldn't be, and that's because we didn't do the leading F for a formatted string, and we need to wrap these with curly braces. So we build this, and now we see jumbled fake in all of those correct locations. Our scoreboard ID shows up in 3 places, so we can replace that, and we'll build this, and we see that still came out correctly, so that's good. And one last thing to fix, we have the shorthand for lives here still, and we're able to format these text components a lot better. So we'll wrap the shorthands with curly brackets and make sure we do a formatted string with the F before the quotation marks, and we'll run build, and now we see this properly. So beyond constants, we can also access functions, Python functions actually. So we're using our Bossbar ID still, and I defined a function that takes a value and sets the max of our Bossbar to that value. Okay, so we should be able to replace this. I'm going to add say doing this so we see the change. And I'm going to do set BB max. And I'm doing that with the value of our starting lives here. Let's build. We check out setup Bossbar. We see the exact same logic, but done through a function instead. Bossbar set jumbled lives max 500. Beyond functions, we have classes. So here I created a new Bolt file under modules called score.bolt. Inside of that, I'm defining a new class, score, with a capital S, and this just has a public variable x, which is equal to 3. Inside of our setup bossbar function, from our namespace jumbled from our score module, I'm importing that score class. I'm creating a new score object with this variable here, and then I'm saying the value of that x field on that score class of that new object that we just created. So in the final data pack, we see say 3. Now this is about to get a little bit crazy. There are tons of examples here, and this is specifically for the Bolt sub package. If we go to packages, we can also see Mecha, and we see examples here. This is where the most of my learning came from because there's not a ton of documentation out. Like the main website, we have the rationale, general overview, and I love that the author of this project, they do have some videos, some screencasts. If we just go to Beet, in the readme.md of Beet, we see these screencasts. These are from Fizzy, I believe, and they go over some different stuff, the pretty advanced stuff that Beet, Bolt, and Mecha can do together. It's really crazy. So I'm really giving you like bare bones stuff here. There is so much more you can do. Like there's the whole, I haven't even touched on resource packs. Like you can create your custom textures and have them generated and then put into your resource pack for you, like through Python code. It's amazing. It's really crazy. So I'm going to come back to this in a moment. We built out this score class. Give me one sec. This part's a bit of a contrived example, but we have this score for our server. We have a scoreboard with a lives objective, and we have a fake player, and we're updating their specific score to track however many lives we have left for the server. When that reaches 0 or a -1, we do the game over, but for now that just spams game mode spectator for everyone. But in the abstract, we essentially have this pair of a fake player and specific objective, and we're using this in a lot of places. Fake lives here, fake lives here, and once we make this prettier, we're going to have another execute under this, and that's going to check the same thing. So this is going to be a bit of a contrived example, but this would really shine in a much larger data pack. We're going to abstract our score stuff here. So this entire execute logic and this removing a life logic, and pretty much all of that is going to be in our score class in our score module. We're going to start small and replace this remove fake lives 1 inside of our onDeath function. So we're going to start with our constructor, which is an overloaded function. So this double underscore init function, this should be familiar if you know Python. We have this self keyword, which references the specific instance of this class. So what we're doing with this constructor is pairing a player and an objective together. So when we do self.player, we're creating and setting the field here, just like we did with X, and we'll have the player and .obj fields on our object to reference. So we're specifically trying to do a shorthand for this remove. So I'm going to define a new function. We're calling this remove still. We're pretty much always going to start with self as a parameter, and then we have n to represent a number. So this will be the amount that we're removing from this player for a specific objective. So let's copy this command over for now. Instead of using a fake player reference, which we're not importing here, we can do self.player, and this is going to reference the player that we gave it earlier. And instead of lives, we're going to do self.obj, and this is going to reference the objective that we gave this earlier. And then at the end, we can replace 1 with n. So now we have a short form for removing any amount of score for any player of any objective. So how can we use this in onDeath? And I'll also pull over the build code so we can reference it. So just like earlier, we're going to import the score class from our score module in our jumbled namespace. Going to create a new variable. I'm just going to call this score object. This is going to be a new score object created from that class. Self is passed in by default, and we have the variables for our fake player name and for the objective lives. So I'll add fake and lives here. And since our score object is of the type of our score class, it should have this remove method where we only pass in one number, and it's going to remove 1 from that objective for our fake player. So I'm doing score object.remove 1. I'm going to comment out this old line. I'm going to add a say hello so we can see a change, and then build the code. Drag this over a bit and drag this and bring this up. And we see nothing really changed because it's the exact same logic, just abstracted away into a class. And we see the say hello I added. We have this logic here. Execute if the score of our fake player lives is less than or equal to 0. We run the game over function, which for now puts everyone in spectator. But let's create a matches method to abstract away some of this logic. So self is implicit. It's always going to be passed in. Then we have a variable, which is going to be a range string. So it's that same thing we saw earlier, these ... 0 or some number ... or whatever. So we have this shorthand if, which is still executing. So we're checking if the score of our player objective is within the range that we gave it, then we yield true, which is basically a shorthand for this segment here. So we have access to with. So we have our score object. We can use with to execute if something is true. So we're checking against that same range, but we're passing it as a string, and we want to do function game over here. So I'm going to take out that old line, We're going to do say something right above that, and we'll try to build this. And we get an error which says generator object does not support the context manager protocol. So to enable us using this with, we need to give more context to what's actually going on here so that Bolt can actually process this properly. So right above our matches function, we're going to add an annotation, which is just context manager, which we imported up there. Then we'll build this again. And now we don't have any errors. And you see this compiled. We see say something, which I added there. And we see the exact same logic for running that game over function right here. Something else we can clean up is actually the scoreboard players set fake lives, starting lives. So we're going to do this with our score class as well. But we're not going to use a method. We're actually going to transform it in a sense. So instead of having all of this written out, we want to have a shorthand where we're basically just directly setting the value. So our score object is created with our fake player and lives objective. We're setting that score to the starting value to replace this longer line of code. So just like the context manager we just had to do, this doesn't work instantly. And this actually creates a lot weirder logic than I was expecting. For some reason, there's now a folder created with a nested execute function, which is empty, but we're going to create an overload. So we have this rebind method, and this is for reference during assignment. So if we're doing like our score is equal to a number, or our score is equal to like -1, we want to be able to do things like score equal 1 or score equal 500 or score equal -1. So this assignment here, we have the left hand side and the right hand side of the assignment. So RHS is the right hand side. This is always passed in like we said before, and that's the left hand of the assignment. So this is instance method is provided to us. So we're checking if the right side is a score object. If it is, then we're doing this self player self objective. So that would be our fake player and fake player objective is equal to another score. And this is a comparison. So that's the same thing we were doing here. We're checking if a player's objective is equal to a player's objective. And this is abstracted in a way that you could use any player and any objective and compare those. So if the right hand side is not a score, such as -1, or what we're doing here, starting the lives is 500, then we're going to run this command. So we see scoreboard player set, same thing we have here. Then we reference the player and scoreboard objective of our score object, and since we get the right hand side as a string, we convert that to an integer. So now when we're doing this assignment, we're checking this rebind method, and we have some different logic that will occur if we're assigning ourselves to a score or assigning ourselves to a new number. Otherwise, we just return the original object. So we'll build this. You see we don't have that weird folder anymore. So these two lines right here, about 70 characters, is executing the exact same logic as this 134 character line right here. So we do, unless the score of our fake player lives is equal to the score of our fake player lives, unless the score of our fake player lives is equal to the score of our fake player lives, then we set the scoreboard objective to our starting lives. So we set our scoreboard objective of our fake player lives to that amount, which is 500. So in essence, we're done, but we still need to make this a lot prettier. If I do /reload, how do we know when it's done reloading? How do we know when we're good to play again? How do we know if it's still going until that message fades out? And then also, when everybody dies, we get put into spectator mode. Well, that's kind of boring. And then we still have this Bossbar displaying. We still have the little lives display right there. We want like a big game over title. You know, we want it to be fancy and then play a sound and stuff, you know? So again, MC Stacker, create a pretty tell raw, and make sure you add the F before the strings with replaced values. We do build, then I can reload in game. And now we see that message appear in chat saying how many lives we have left, and it looks pretty fancy. You'll only see this after the reload command if you're just starting the world. Any MC function that happens during load happens before players are actually in the world. So we saw that we could do scores inside of text components here. If you look through the different text component types, you can see player and selector, and we're going to be using selector. We're adding a new tell raw to the onDeath function. So this runs every time somebody dies. We're using the @s selector to get the player name. Then we're saying that they died. Then we're adding a score component at the end so that we can see however many lives the server has left. So I'm going to build this. I'm going to reload. Give us an extra life. And now if I do /kill, you see a message in chat. I am Jason13 died, shared lives remaining 1. And that's the same amount of lives we have left on that fake player. So now we want to change the game over sequence. So I'm thinking when a player dies, we hit 0 lives, a title pops up, and we play a sound to make it a little more thematic. So we're going to make this a little bit multi-part. So we hit 0, and at 0, we run the title stuff and we play our sound, but we don't want that to repeat every single tick if we're staying at 0. So after all of that happens, we're going to set our lives to -1 to prevent the title and the sound from constantly repeating itself. And before that, we want to clean up the boss bar and clean up this display here so the player doesn't see -1, because that would be a little bit odd. So instead of our score being less than or equal to 0, we'll do game over at 0. And then if it's -1, we'll take this and we'll do game mode spectator for everyone if we're at -1 or anything less than or equal to -1. So we're going to import the basics. We have our constants and we have our score. We'll create a score object to reference that. So when we're hitting game over, our lives would be equal to 0. So to get our lives equal to -1, we need to remove a life. We did something earlier. in scoreObject.remove in our onDeath function. So we can do that, or since we added that rebind overload, we could just set it directly to -1 this way. We can create our title and subtitle components separately and then use them in our title command. And as well as the titles, we'll also do a message in chat that the server ran out of lives. So we can add a little bit more detailed, a little more emphasis on what happened. We can also change our Bossbar to no longer be visible. So now we can finally use visible that we saw in the beginning and do Bossbar set our Bossbar ID visible to false. So we also want to play sounds, and this is a good point to touch on macros, which are completely separate from Minecraft function macros. So Minecraft function macros weren't added until Minecraft 1.20.2, and they're completely separate from the Bolt macros that we're about to go into. In our modules folder, I'm going to create a new file, call this macros.bolt. So macros are kind of like functions. Instead of def or define, we have macro as our keyword, and then for the name of our macro, we have play sound broadcast. And this will take an argument that we're going to call sound of the type of Minecraft resource location. There's a ton of these types built in. There's Brigadier string, Brigadier int, or whatever. Brigadier being Minecraft's actual command library that this whole project is kind of based on and built around. We're going to stick to using this simple example, play sound broadcast, but it can get a lot more complex. So we have macro as our keyword, play sound all, and we have play sound all twice. Now these are still different methods because they have different parameters. So this one takes sound as a Minecraft resource location, and this one we're doing a default volume and pitch, so that's at 1. And for this one, we're doing pretty similar logic, executing at the player to play the sound at their position with a specified volume and pitch of the types Brigadier float, Brigadier being Minecraft's command library, and Minecraft resource location for the sound. So to use our macro play sound broadcast, first we need to import it. So from our namespace jumbled, from our macros module, we're importing the macro play sound broadcast. So we can use that here, play sound broadcast, and we'll pass it a resource location of a sound. So I'm doing Minecraft entity.wither.hurt. So if you want to look through these, just play around with play sound in the game, and you'll see all of these ambient sounds, block sounds, weather sounds, UI sounds, music, items, entities, etc. So play sound broadcast, and it's specifically using this raw text here, so we don't have to wrap it in quotation marks, I think. So we'll build that. So that built as expected. So let me do reload. And then we were at 0 lives, so we get the title, we heard the sound, and we see the messages in chat that we're at -1. Now we still have this display here. We still have that orange lives display. So we want to conditionally display that. So that's coming from our action bar here. So we only want that to display if the score of our fake player lives matches the range of greater than or equal to 0. So I added this if score blah 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 matches that, then I'll just take this back here. So we run title at s action bar for all players, and I'll build this, and I'll reload, and that fades away. So if something happened and all of that game over logic happened, the action bar comes back, but the boss bar didn't come back. So if the score of our fake player lives matches that same range of greater than or equal to 0, then we'll run boss bar set jumbled lives visible true, and that's to make sure our boss bar comes back if we're greater than or equal to 0 lives. So I'm going to put that in on tick, build this, then I'll reload, and our boss bar comes back because we have greater than that many lives. So we'll do kill one more time. We see game over, the server has run out of lives, and we're in spectator mode. So obviously there's so much more you could do. There's so much more to get into. There's tons of examples on the GitHub for this, which you should definitely explore. Go look through that, because oh my god, I haven't touched on half of what's actually possible. Oh my god, I haven't even touched on the pipeline system, so I might do a whole video on that by itself. And then Lectern, oh my god, we gotta touch on Lectern. So talk about insanity. Editing Datapacks involves a lot of jumping around between files. For simple use cases, a single file is a lot easier to work with, and I agree, our entire thing could have been done in a single file. Now, let's look at this. Function, tutorial, greeting, say hello world. What's going on here? This markdown file is interspersed with code fragments describing the content of a Minecraft data pack. Using Lectern, you can turn this single file into an actual data pack that can be loaded into the game. So, okay, insanity off rip. Like, what are we even talking about? So Lectern, you can use as a command line utility to turn the markdown file into a data pack. So we would do Lectern tutorial.md and then give it a path to a data pack to export that stuff into. So if we're using Beet, you can use Lectern as a plugin in our pipeline. So I have a new project, a new beet.json. Our pipeline is just Lectern, and we're adding some metadata for telling Lectern to load any markdown files that it finds in our root directory. Now we could also do source, do new folder source, and move that here, and that should be completely fine. So markdown files are typically used for README files, which tell you about projects, and they're located in the root of projects. So we'll actually do it just like this. We'll search for any markdown file, and we're going to have our readme.markdown file in the root of this directory. So markdown files are rendered text, essentially, so we can do titles and stuff, and Visual Studio Code allows us to open a preview to the side. So if we do that, we see that titles are really big, obviously. We can also do highlighted segments like this, or highlight specific portions of text like that. So to use Lectern, obviously this is one of the best examples is right here in their README. We can click on the README file and go to code to see the actual raw stuff behind it, and we see how they're defining functions. So what if we just tried to copy this for now? I'm gonna do lectern -d, give it out as a folder. So we run that. A new folder is created, named out, and we see pack.mcmeta here. So this automatically generated some pack.mcmeta information for us, but we don't actually have that function here. So here we go. I had to update my beat.json a little bit, so I provided it a name, and I'm just giving it jumbled again. We're using the Lectern pipeline, still giving it the same metadata. Then we're gonna output to the build folder, and then I'm telling it I'm using this Minecraft version. So we see here, just by describing a function, giving it a namespace and a name, and then adding contents to it, the build reading.mc function has that same say hello world. So we're getting super meta. We have a self-descriptive document basically. We're starting with this @datapack annotation and describing a file pack.mcmeta, which is our data pack, giving it the pack format and a description. And now we have a setup load reload section here. We're setting up our scoreboard objectives and executing unless our scoreboard lives is equal to our scoreboard lives, blah, blah, blah. We've been over this, but we're also tagging that in a separate section with function tag Minecraft load. So off rip, you can kind of tell what this is going to do. We went over the tags earlier. We went over these commands. So we go on, we're describing player death handling, removing a life from the server lives and resetting the death objective, then doing game over handling, putting everyone into game mode spectator, and then doing our tick logic, executing if those things are true, and then we're tagging that tick function. When we actually do beat build, we have our beat.json set up. So this creates the same pack.mcmeta we just described. We have the JSON files with our functions tagged, and we have our functions created, game mode spectator for everyone. We have our onDeath function, our onLoad function, and we have our tick logic. So all of this, the entire data pack generated the core logic from a single markdown file. So we've touched on Beet, Bolt, Mecha, and Lectern and how we can apply them to data pack development. This was a step away from my typical content, but hope this has been educational and given you a sense of what's possible with data packs. There's still some limitations here and there, but as long as you can build off of abstractions, you can achieve just about anything. So it's your turn to create or teach me something handy in a comment. I might go back to my regular content soon, I'm not sure yet, but I do plan on creating more content about Minecraft and programming mods and data packs in general to give an edge to the next generation of creators. So thank you for watching, thank you to our channel members for joining, and thank you again to Brilliant for sponsoring this video.